So in order to be able to compare the effectiveness of different algorithms, should there be a standard set of basic test scenarios? For example, moving towards from 10 meters, moving away, moving tangentially, person or people in between, BLE device in hand, pocket, backpack, indoors, outdoors. I know there are a lot of possible variables, but a base set of scenarios would be helpful. Well, we are here in week 5. I think it's a little late to provide a base set of scenarios that we would expect or hold everyone to, not that it wouldn't, and furthermore, wouldn't necessarily apply to everybody's project focus. I think the best thing I could do is say that there, if you look at the overall PiPACT Bluetooth contact tracing for COVID-19 in particular approach, there's fundamentally 2 metrics, we're using in terms of what constitutes, exposure and non-exposure: too close and too long. And so, if you look at those, and we, sort of general guidance right now based on social distancing guidelines and other guidelines is, too close is within 2 meters or within about 6 feet. And too long, this varies, depends on who you ask, but, it can be 10 to 15 minutes. So if you look at those qualifiers as the sort of, on either side of those 2 boundaries, right? So for distance, it's there's situations where the 2 devices are further than 2 meters apart, and situations where devices are within 2 meters. And then there's the other metric, the time aspect, situations where the devices are close enough or too close for 10 minutes, or they're not close enough, or they're too close but not for 10 minutes, or whatever the time. So there's like 4 combinations you can assess there. And then, of course, what you layer on top of that is any specificity that your hypothesis is trying to address. So for example, your hypothesis is trying to assess the impact of having obstructions in the way. So depending on the nature of the obstructions, if you have one type of obstruction you're testing, like let's just say it's a sort of quote unquote standard human body in between the 2 devices, then 4 base sort of configurations becomes 8. That's one way of thinking about it. But there's, and again, we don't want to seem too hands off or too sort of throw you to the wolves, but it is an independent project. You guys are, one of the biggest things is for you guys to come up with that sense of what establishes the baseline and evolve it. And it's going to depend on what your project is focusing on. Maybe this might feel like a non-answer, and I apologize. But whoever asked this question, if you want to put forward your hypothesis, and sort of get more specific about what may be baseline scenarios, then we can definitely comment on those. But I don't believe we can offer anything that's sort of all encompassing, or at least a common level set. I could offer sort of scenarios which you can get familiar with, how to do data collection and how to do sort of the compare and contrast of those 4 basic scenarios I initially discussed related to distance and time. And if that's what you're interested in, then I can definitely follow up with that, but that might not directly address what your hypothesis is trying to answer. Where can we find the template for the final report? When the template for the final submission be sent out? Sorry, I'm a bit of a grammar Nazi, so I will avoid saying things too much. But So that said, we will be posting the template on Sunday. Okay, we made this announcement last week, and also in the reply to the question, there was a question on Piazza about this. We've also provided in that Piazza question the sort of rough outline of the topics we expect the final report to address, but we'll give the formal template on Sunday. Again, we ask for your patience. You just have to remember all of us have day jobs. So we really had to work on this in our spare time. So I think that answers that next question. Okay. I feel there are too many variables to control and measure RSSI values. My main goal is to, sorry, let me restart that question. I feel there are too many variables to control when measuring RSSI values. For example, orientation of pies, what surface they are sitting on, height of pies. My main goal is to see how putting pies in pants pockets affects RSSI. Is it okay to have other variables that might affect these results? Absolutely. I guess the point of almost any type of experimentation you do, unless you're doing your experimentation in like perfectly controlled lab conditions where you can control you can control the environment, you have precise measurement tools and all that stuff. Any actual experimentation, any actual data collection are subject to the same sort of uncertainties that you experience. I know when I do my day job involving airborne radars, right? We fly sensors on airplanes. I hope that when I fly those planes through the air with the radars, that the environmental conditions are what I expect them to do, that the pilots are flying the flight plan that I hope they're flying, that the radar is being, the timing on the radar is accurate. These are all things I try to control to the maximum degree possible, but knowing that a number of them won't be in my control. And so it's not so much the requirement that you absolutely control everything or absolutely document everything. You should when you can, but it's more important to be cognizant that there are factors that, when you observe a trend in your data, right, and you're trying to, and your data is supposed to be reflective of what would be independent variables, right, the free variables that you're trying to actually correlate the data to that variable. So for example, in that case, the effect of being in the pies being in pants pockets, that you have to recognize that there may be other factors present. And the best way to sort of adjudicate this, right, is to either be as repeatable on those other factors. So, right, when you put the pies in the pockets, that you orient them the same way, or that you, use the same type of pants, or whatever else it may be, as much as possible. In addition to that, just collect as much data as possible, right? And where that when you are varying, when there's one variable you're actively controlling, you're actively varying, and you see correlation between that variation and behavior in the data, that you can more confidently say that those two things are actually correlated because of the preponderance, because of the amount of data you have. It's important to recognize that correlation is not causation, but as and as you might suspect, in almost any sort of data-driven experimentation, the more data you have, the stronger your conclusion can be, but you have to have that more data. Wow, okay, so I have taken 10 hours of data for each region. Wow, all right, congratulations. That's a lot of data. Half meter to 2 meters in steps, and 2.5 to 4 meters in steps. But the histograms are not distinctive. The peaks are very close, and the data is highly distributed. I also tried 2 fixed positions like 1 meter and 5 meters and still got very similar data. So I am kind of confused. Well, good question, or maybe a a good summary of what you've done, what you've observed, and sort of an open sort of query. I would say so. Obviously, there's a lot of stuff going on. That what are the? Do you think there are other variables that might have affected? How much did you? How repeatable was your configuration from these different distances you measured? If they varied greatly for whatever in whatever ways, then maybe those widely distributed histograms make sense, right? Because they're capturing more than just the distance variation. However, if you did control a large number of what you think are the most impactful variables, for example, you always had, there are no obstructions. The pies are always oriented the same way, at the same heights, that it, there, and so on and so forth. And the data you collect is you feel is most reflective, or is supposed to be most reflective of the distances you measured. Then why am I seeing something that doesn't seem to correlate with the whole PiPACT goal, right? That I should be able to correlate the RSSI values with the distance. So there's two things to remember here. One is that with those ranges you mentioned are relatively small differences in range. Okay, so generally speaking, from a RF, a radio frequency propagation perspective, so how strong do RF waves, how does the strength of RF signals vary as a function of distance? So in this, what we call a one-way link, where it's one object is transmitting to another. This involves what we call an R-squared propagation loss. So for R being the distance or the range between these two devices. So as the range changes, the propagation signal or strength changes proportional to R squared. So if I had two devices at, let's say, 1 meter apart, when I double the distance between them to 2 meters, the signal strength actually goes down by 1/4, right? 2 squared. If I increase the distance to 3 meters, it actually goes down by 9 times, 3 squared. Okay, because that's the relative ratio between the two ranges squared. So you are seeing relatively small differences. And remember, what you're seeing is decibel values, right? So to remember, decibels are 10 raised, or 10 times log 10 of the number, right? So, to give you an example, if you have a signal that's minus 3 dB, right? So bringing it down by 4 is minus 6 dB. So it depends on what the range you're looking at is. If you're expecting really big differences, like 40 or 50 or whatever, or 30 dBm, you're not going to get that necessarily just by doubling the range between them. You're going to have to go further. Another thing just to keep in mind is that, a lot of trying to do this with PiPACT is a lot of people are still trying to figure out how reliable using Bluetooth is for this application. Your results may just be evidence that Bluetooth is not necessarily, at least in the regime you've tested, is not the most reliable way to measure, is to correlate or measure distances. And that's a perfectly valid argument to make. If you have the evidence, if you can show the evidence on the back of a well-structured, well-executed set of data collections and analysis, indicates that that is your conclusion, then that is your conclusion and you should stand ready to defend it. If you don't want to make that conclusion, if you really are like all in, you're not willing to budge off of correlating distance with Bluetooth, then you're going to have to do more analysis. You're going to try to have to figure out those factors that may be causing these histograms not to be as distinct as you might like. Again, I don't have a crystal ball that can necessarily untangle your particular scenario, but I do want to remind you that, this is part of science, a part of the exploration of new ideas is sometimes you find the base hypothesis does not stand up. And, whether you're willing to move from it or not is your choice. And once you make that choice, then you kind of know what to do next. Untangle the mystery, or proceed down the road where this is my new hypothesis, this is my new conclusion. Okay. So next question. While I collected data, I noticed that some of my results didn't match the predicted result based on research papers I read about RSSI. Should I continue testing to see if it was an anomaly, or include this data in my report? So this is a good question. They're all good questions, by the way. But this is an interesting question that goes to, what your research alone is not going to necessarily be the end all be all, or the sole justification to implement the system or to go all in on Bluetooth for contact tracing. It's going to be an aggregation of lots of work, yours included, hopefully, and that the solution should be the consensus, right? So what happens when we don't have consensus, where your results don't seem to agree with others? Well, obviously, the first thing to do is to understand that is your work and the work you're comparing to based on fundamentally different approaches or assumptions, right? So one thing I might ask, without knowing necessarily what these research papers are citing is, are they looking at pies? Are they doing their data collections in the same sort of physical and environmental setup that you're doing? For example, if you're doing this more than likely in your house, outdoors, somewhere you have access to. But maybe these researchers have access to anechoic chambers, or they're using Bluetooth test equipment, like high-end Bluetooth test equipment to do this, where they can dial in signal energy and they can precisely control things while you're a little bit at the mercy of what the GATLib and BlueZ software stacks are doing, right? Where they're doing power cycling and frequency hopping and so on and so forth. So you should first ask yourself, is there even an apples to apples comparison here? Because, if they're looking at like, iPhones and you're looking at pies, then the hardware is entirely different right off the bat, right? I wouldn't be confident in making comparatives of RSSI value, comparing their results to my results just on the basis of that. Maybe the trends are things I could look at, right? Where they're sort of saying like, the trend line of how RSSI decreases looks like this, and this is the general shape that should follow based on physics. But the sort of offset that I see, right? Like maybe the iPhone has a stronger Bluetooth transmitter than the Pi does. So the signals they receive are generally stronger than the ones the Pi receives or transmits. And that's a bias. So that's one thing I would look at. The second thing I would say is don't ever throw away data just because it doesn't agree with somebody else's results. There's nothing that either invalidates your results or invalidates theirs. You should put it forward so that this discussion can happen. It's definitely, I personally will be very interested to read about, not only what you collected, but how it compares to others. And out of that, hopefully that just, that identifies, what further investigation is required. Because clearly, if these two things seem to be in contradiction with each other, there has to be some sort of resolution between them. Either one is right and one is wrong, or both are sort of slightly right and slightly wrong at the same time, and the right answer is somewhere between them. And knowing which direction to go only comes out of being able to do the comparatives between them and having the following discussion. So include it, please. What license would you recommend we use when we create a repo on Git? So that's entirely up to you. The code you write is your authorship. Obviously, if you're modifying the reference code, we just ask you to use the MIT license and just cite it. Just cite it according to the MIT license. But we don't necessarily hold any rights to it. I would say either, BSD clause 3, GNU, or MIT license would, if you want to apply a license. If you intend to commercialize this, I'm not necessarily or you have plans, that's on the trajectory of how you're thinking. I'm unfortunately not the right guy to ask about that. I don't know, you can put that up on Piazza, and hopefully maybe John or somebody else can comment on that there. But we're not requiring anything. Definitely not by virtue of us expecting to necessarily use, reuse, or share this. So if you want to lock things down with a certain license, then by all means do. We just ask that you share it so that we can understand what you actually did. If we do plan on sort of leveraging that, we can reach out to you and work out those details. But I hope in the spirit of what this whole program is trying to accomplish under the larger Bluetooth, PiPACT, Bluetooth-based COVID tracing, COVID-19 mitigation efforts, that you use some open source license so that we can all benefit from the good work you guys are doing. All right. Next question. Is it fine if our experiment is not completely done by the deadline? For example, I've collected my data and arrived at conclusion, but I also wanted to implement an algorithm to counteract the change and make the detection more accurate. Absolutely. So we're still going to hold everyone to submitting a final report for the purposes of the independent project by next Sunday. All right. So that's 9 days from now, and the template will go out on. Trust me, we're not looking for. I mean, you can make it a novel, but I can tell you we're expecting something like a pretty standard like 4-page conference paper. It's not going to be super long. You have to just be concise. To fit in 4 pages, you may have to be concise, but what you want to capture in that final report is the work you've done up till then. And anything more you want to do, capture in the next steps. And we'll be very interested to hear from you in post. We'll leave the Google Drive open for a little bit, that you can update your report, you can share more results. But keep working. And obviously, we will, if your concern is that, since it doesn't feel complete, that you won't necessarily get a pass or a completion on the independent project, I would say you would only necessarily be at risk is if the work you've done up to this point doesn't feel like it represents what we would consider 6 weeks of work or a reasonable amount of work, and that the steps you're taking next seem like a good amount of work as well, right? At the end of the day, it's a lot of good efforts, good faith effort that we'll adjudicate this by. And I think if you can describe what you plan to do next beyond that Sunday, that'll go a long way towards making sure you get a completion. But please, by all means, continue working on it if it continues to interest you. But if you, at the same time, if you submit the final report, move on. If you want to move on to bigger and better things, by all means do. We just are glad to have given you this opportunity. Okay. Next question. Ooh, this is a long one. I trained a TensorFlow Keras model to predict distances from RSSI values collected when pies were in line of sight at 0.5 meter intervals from 0.5 meters to 3 meters. Had a mean squared error of 0.327 meters for data the model had never seen before. What should I cover in the experiments/data collection section of my report? Should I include histograms of my collected RSSI values, or should I include my mean squared error over time as the model trained? Basically, how should I separate my experiments/data collection sections and analysis/algorithm sections? Good question. So obviously, the way you've approached this is you're using the deep network, or it depends how deep you consider this. But let's just call it a deep network since using Keras to basically estimate distances. You input RSSI and you estimate distances. So it's an estimator, right? It's not you could also maybe call it a classifier, but it sounds like you have a more continuous, you're doing something more akin to a regression. So I'm going to call it an estimator. The way I would look at that, right, since the algorithm you developed isn't quite the sort of binary hypothesis algorithm that I discussed or sort of gave you guys a crash course into last week when I talked about detection theory, I would consider that your algorithm/analysis, right? And I'll put that result there. So in the experiments and data collections, we want to see the construction of how you use the pies to collect RSSI values and the type of data you collected. So we want to see histograms, PDFs, CDFs, what other format, but we want to see sort of the representation of that raw data, that raw RSSI values. And so at the end of the day, right, when we look at all these reports, we know that in that section is what people collected using the hardware, right, using the pies. Subsequently, in the analysis or algorithms is what they did with that data. And so in your case, you might show how the training error converged, or you might demonstrate different like cross-validation, what is your cross-validation variance, right? Or if you had a true holdout, or leave one out cross-validation, or whatever other sort of approach you did to assess the accuracy or generalization power of your algorithm, that should go there. That's how I would separate it in your case, but I think generally speaking for everybody, I would put in the experiments and data collection section that we'll give you the template for on Sunday. That's where you want to be presenting the manner in which you collected data and the actual raw data you collected. I mean, we're not looking for spreadsheets. If you want to give an example, that's fine, but we're looking for more of the aggregate, the histograms, the PDFs, the CDFs, the line charts, whatever else makes sense to you, whatever you think conveys things. That being the case, what goes in the analysis and algorithms is going to depend on what you're doing. Some folks aren't doing any algorithm design. They're just trying to figure out the phenomenology, right? Is RSSI a good way to separate these, like based on my hypothesis, separate these two situations or these two configurations? And their analysis is more a, doing the sort of manual analysis of the data to see, is there separation, right? If there isn't separation, why wasn't there separation? And those of you who are doing algorithms, then obviously what goes in that section is what was the design of your algorithm, describing that, how you went about implementing it, how you went about refining it, what the results were with that algorithm. So it's going to vary based on what you guys are doing, each of you are doing, but I hope that answers that question. I've noticed when feeding my data to some machine learning algorithms that training the algorithms with humidity and pressure data from only the scanner pi significantly increases the accuracy of the models. How feasible is it for smartphones to sense this kind of data? Interesting question. So I'm going to first give you a caution, right? A caution. Usually when you feed, so anytime you feed in metadata, right? Metadata that is not necessarily correlated or not necessarily representative of the variability in the scenario, right? And the variability in the scenario you're trying to capture or control. by virtue of the algorithm. So for example, estimating the distances or telling when two things are far enough or not far enough apart in a more sort of binary classification approach. You just want to be careful introducing those meta parameters, because sometimes those meta parameters are directly associated or correlate with the variable you're trying to measure as well. And they come basically false surrogates for the label. A good example I would, a very simple example I would give, I'm trying to think of a toy example. Well, I'm trying to think of one right off the top of my head. But maybe a very naive example, right, is if you're trying to discriminate, person A from person B, right? And for whatever reason, you have a piece of metadata that says that person A wears a red shirt and person B wears a green shirt, more often than not, right? And that and you're putting in the color of the shirt. Is that what you're trying? Are you've effectively created a shirt recognizer, color recognizer that is, coincidentally correlated with the people's identity. So that's kind of what you want to avoid when you bring in other things. I'm not saying that's necessarily what's happening in your case. Maybe there isn't that correlation. But anytime you bring in a piece of metadata, something like humidity, temperature, orientation of the pies, you just want to be careful that you're not teaching your algorithm to recognize that variable, right? And that variable happens to be correlated with the label of what you're actually trying to recognize, right? Or actually trying to train on. So that's one caution. Now, going back to the other, let's assume it's not. Let's assume that's not the case, where it's not correlated with what you're measuring. So how might you get this on a smartphone, right? What is the practical way of getting this piece of data? Well, if you go on Kickstarter, there's no shortage of humidity. I've seen my fair share of Kickstarters where people are trying to get built-in weather kits, like a case you put around your phone that provides a weather kit. Obviously dubious. I have my doubts on their accuracy, but that said, a very coarse way to get it that might not necessarily be at the sort of macro, or be at the micro or local scale that you are currently able to get using the pies and what I can assume is an additional sensor you've acquired, is local weather, right? Historical weather data. And that obviously has its limitations, both spatially, right? You don't necessarily get weather reports where humidity measurements are down to your house, let alone your town. They may be over larger metropolitan areas. And also time, right? They're not necessarily giving you them at the time increments that or the fidelity that might be needed for your way of the resolution that supports increased accuracy. You may only get them twice a day. And humidity obviously doesn't change 2 times a day. It changes continuously. But it might be worth exploring is like at what resolution is it necessary, right? If I use a piece of humidity data that is plus or minus 1 hour, right, from when the data was actually collected, the RSSI data was actually collected, how do my results vary, right? What is my sensitivity to that? And how far can I take that, right? If I'm good plus or minus 1 hour, am I good at plus or minus 2 hours, plus or minus 3 hours, or how far can I push this? And having that piece of knowledge may either say like, look, we can work with weather reports alone because the algorithm's tolerant to having weather data that's not necessarily time aligned or has this much slack, or we have to have something finer. We have to have something better because the weather reports aren't cutting it. We have to have something that's more local. At which point, we'll have to see maybe what's on the market, but at the same time, consider the fact that, maybe the smartphone isn't the way to go. Maybe we had to go with more of a system on chip, like, an Arduino or a Raspberry Pi or whatever. I know smartphones are what is being targeted by PiPACT and whatnot. But if you bring a good case for why a smartphone limits a good solution, and that another device or another platform is a way to enable that better solution, then it should be considered. You should bring that argument, that story to bear and have that discussion. So I'm very interested to see what your results show. I think okay. So we answered that one. Is it fine if our experiment is not completely done by the deadline? Oh, we answered that one too. Oh, sorry, I'm not looking at the right tab. That's the answered questions. Do we have to make a contact tracing algorithm, or is an RC graph for RSSI under various conditions okay? Where the algorithm is just declaring that the RSSI less than 6 feet is RSSI is greater than a certain constant. Absolutely. You don't have to write a single piece of code. You do not have to, you don't have to come with, what you've described is what we would call the critical value test, right? Where you've defined a threshold for RSSI, and on one side of the threshold is the null hypothesis or hypothesis 0, and the other side of it has hypothesis 1 or the alternate hypothesis, which in your case is, sounds like, too close and not too close. Absolutely, no need to write any code. Obviously, if you're going to be doing this sort of manually, just looking at the histograms or just looking at the values, you're going to have to do that manually, right? And I'm hoping you're not doing it by pen and paper. It's an Excel or something that lets you sort of count how many values are greater than this and sum up that number of counts and see how many times you're right versus wrong. So absolutely. You don't need anything. An algorithm, remember, if you go back to the basic definition of an algorithm, I can't remember quite the original Greek definition, but it boils down to a recipe. And by no means does a recipe have to be automated or fancy or complicated. The recipe can just be as simple as saying, here's the threshold. If you're greater than the threshold, you're this. If you're less than the threshold, you're that. So by all means. Can we create a sort of database for all the RPI data collected so that we could potentially leverage it for future solutions? Absolutely. That's one of the things we're hoping to do once everybody posts to the Google Drive. We haven't created it right now because a couple of reasons. One, obviously, we want you to move forward with sort of just owning a solution yourself. If we had posted all the data, you guys might spend more time looking at all the data than doing anything, right? Than moving forward. So we wanted you to go through at least one iteration of this under the auspices of the project. After that, all the data that you guys collect will be posted, and hopefully with the report that accompanies each of those sets of data will help anyone who wants to go look at that data will be able to look at the report and sort of understand what the data represents in terms of how it was collected, let's start from the beginning, why it was collected, how it was collected, what was taken away from it, so on and so forth, so that they can then look at it, maybe look at it a different way, make different conclusions, so on and so forth. So we'll post that if you continue to be interested in doing that, but we will hold back for the moment on sharing making the Google Drive version of that database available. I will say though, if you would like to make an open solicitation to your fellow participants on Piazza about sharing data, by all means do. Anybody who wants to share their data via another mechanism, right? You guys can email each other directly or set up your own exchange sort of mechanism. By all means do. We will not get in the way of that, but the officially sanctioned version won't come until until we open the Google Drive, which will probably be towards the end of next week. And then we'll make an announcement that is available for folks to peruse at their leisure. All right, so I don't have any more questions in the Q&A. So we might end a little early today. So somebody is asking, can I email you about this later? I think I know who that is or what they're referring to. Yes, by all means, you can. If folks continue to have questions, so apologies to those of you who sent me more hypotheses. All in all, I answered, probably close to 60 or I don't know. There was a lot of hypotheses that came in, so it took me some time to get through all of them. I think there's still a few outstanding. It's just been busy. So I'll hopefully get to them shortly. It's a little late in the game, I know, and apologies, but have faith that you've probably done the right thing. And all we're doing is offering you advice on how to make it more clear, more tractable. But yeah, by all means, continue to use the PiPACT email address to send us questions in addition to Piazza. I will say this though, try to focus your questions if you're going to email us them. We do not intend to have like an ongoing, create a huge email thread. We want to get questions that are sort of like one and done to the maximum degree possible. I know this is research, one and done seems like a misnomer, but we had to keep things sort of tractable to the point where we're not, we're sharing resources amongst as many of you as possible, right? That we're trying to do as much due diligence as much as possible. So try to craft your questions with as much precision and with as much specificity. Bullet them out, make them concise. If you can get directive questions that are directives that are like, I'm looking for a reference, or do you think this is a good idea? Or I am observing this, can you come and give us that example? Can you comment on this? If there's a question about, I've done this and I'm running up against a brick wall, what do I do next? You should come with some ideas of your own, whether you think they're good or bad. We can comment on those and then help and then springboard off of those, but we're not here to solve the problem for you. Okay. There's a question. This is a follow-up to my previous question about Keras regression model. What are your thoughts on using that model as a binary classifier when the practical distance is less than or greater than 2 meters? If I did that, would you also recommend using the binary classification statistics strategies? So that's an interesting question. When you think about how, if you train a deep network to basically do regression, and then use that regression output as to then do a subsequent classifier. And I would assume using that subsequent output with almost like a threshold. You could accomplish almost the same thing by putting one extra layer with a single node, right? Because all you're doing, if you do a ReLU, like a rectified linear unit, and you do a soft max or maybe just a hard max with a binary output 1, 0, then you would ostensibly expect the classifier to learn what it has to do to that regression output, which is now your second to last layer, to deliver the right 1 or 0 decision. That might be overkill, right? It's not hard to look at those regression values and then draw a threshold. That's effectively what it comes up with. And obviously you can do more interesting things with more nodes in that last layer. You can have a multi-threshold partition if you had multiple rectified linear units or other sort of more hard max associated functions. But regardless of what you do, yeah, I would absolutely recommend using more binary classification statistics strategies. So, you could use pretty standard sort of Bernoulli statistics. You could just use a MLE estimator or a min-max estimator. There's any number of binary strategies. You know, if you want to throw it in a support vector machine, the output you get out, right? You're getting out a single number out of this regression model, right? So that your feature space now is a single line, right? It's out. So now you're trying to figure out how do I partition this 1D space so that either, so one half of it or some portion of it is one hypothesis and another portion is another hypothesis, or multiple disjoint regions form one hypothesis and then the complementary section forms other hypothesis. All of those have very valid binary statistical strategies to go, and you might just have more, what I would say, you might have more guidance, more sort of historical basis is how I might describe it for using those strategies than arbitrarily adding on an extra layer to a Keras model, right? That you think is doing this, right? Is just applying a threshold or maybe applying a few thresholds or whatever it may be, versus these other methods, which are, are much more closed form mathematical solutions, much more mature. But both, will probably lead you to fairly similar results, hopefully. Just, I would say, the difference is the sort of maturity or the basis which you can make the claim that you're approaching the binary classification task in a way that isn't sort of the black box of deep learning. And sorry, you sort of turned on, that question sort of turned on I do this in my day job, so you got some of that, my brain, that part of my brain here. So excellent, a very interesting question. So whoever's asking this, I'm going to be looking forward to your report. It sounds like very interesting work you're doing. So we have 10 minutes. I will give it a minute for one last question before we just end a little early today. Again, I'll just remind everybody the final template is coming Sunday at the latest, if not tomorrow. It will be we'll post a Word template along with just a PDF version of it. And again, they're just guidelines, and sort of, we're not holding you to formatting, not holding you to the tool you use or the font or whatever. More that, you should have these sections, and in these sections you address these topics, and give you some guidelines on when you make charts, how you should label them, what we're expecting. And it's all sort of pretty standard, good scientific, technical writing skills that you guys, if you don't already have, will develop in the future. So nothing is sort of not standard in this community. Make it your own, but remember you want to meet sort of a minimum bar of both content and transparency. Okay. All right, so with that, all right, last question. That's it. I'm cutting it off after this. All right, follow up to the humidity/pressure question. If I'm only actively varying distance between the pies and trying to predict distance, would the false surrogates be an issue? Right. So again, it sort of goes to, so follow up to the humidity/pressure question. If I'm only actively varying distance between the pies and trying to predict distance, would the false surrogates be an issue? No, at least unless it so happens, and you can look at your data to determine this, that every time you move the pies to different distances, that the humidity also changed. And it changed uniquely in the same way the distances change. So for example, just to make it concrete, millibars, I think millibars is a unit of humidity. I'm bad at this, but it's a unit of pressure, but it's also, let's just say humidity in terms of percentage, because But let's say, you're at 1 meter and the humidity you measured was 10%. And then you moved to 2 meters and the humidity was 20%. And you moved to 3 meters, the humidity was 30%, and so on and so forth, where every distance had a unique humidity. Then you might have an issue with that humidity being a false surrogate, right? Because now it is correlating with the distance. Now, on the other hand, when you measure the data, you don't see that uniqueness, right? 1 meter has 10%, 2 meters is also 10% or 11% or something close, but you don't, or maybe you collected lots of 2 meter data and it varies, right? Where the humidity wasn't constantly 10%. It had a spread between like 10 and 15% or whatnot. So as long as you don't have that uniqueness, or a really strong sort of relative uniqueness between the distance and the humidity you measure, I don't think it should be an issue. I don't think it should be an issue, but you should be able to look at your data and establish, right? Because you have both. You can look at that what we would call a joint distribution of how the data varies both RSSI and humidity, and see, do I have distinct modes in my data, distinct humps in my 2D histograms that are correlated with the distance and humidity at the same time. If you have a concern, by all means, you can generate that data or make those graphs and shoot them over to us via the PiPACT email, and I'd be happy to give you a quick assessment of whether I think that you might have an issue with the false surrogate or not. But my instinct says no. Humidity, on an average day, I'm assuming you're not collecting, you haven't reserved, since you started this, it's not like day 1, collect 1 meter data, day 2, collect 2 meter data, that you're collecting data sort of relatively similar proximity of time and environmental conditions, and that they'll have overlap, that they won't show these sort of false uniqueness, false surrogates. So, but that's, you never want to write anything out. You just want to go and eliminate it from being a possibility by going and inspecting the data you have. So with that, I'm going to say Q&A is closed. I hope everyone's at least been engaged. I never claim fun. I won't claim fun until it's all said and done, but at the end of the day, I hope you guys are continuing to sort of get a taste for what it means to do research without a formula, right? Because research with a formula is just merely execution. What you're doing is research. So I hope you're at least taking away from that some new skills, some new perspective, and obviously experience. So with that, unless Lisa or Joel or John have anything else they'd like to add.
No.
Thank you.
Yeah. Have a good weekend.
Have a nice weekend.
All right.
See you guys later.
Yes. I hope everyone has a good weekend and stay safe. And we do have a discussion on Monday along with, there's no seminar on Monday, but we do have a discussion scheduled just to go over the final report.
Okay.
All right. Thank you all. Have a good weekend.